6010 root pass. That root pass sets the foundation for a sound weld, correct? I'm gonna walk you through everything you need to know from prep to execution. Let's get into it. Now, before doing any welding, proper prep of that material is gonna be key on this. So material thickness, we're using 3/8 of an inch. Bevel, 37.5 degrees on both plates, giving you a 75 degree included angle. Root gap, between 1/16 and 3/32 of an inch. Root face, around 3/32. Backer bar, we have none. This is an open root. Now, the single most important thing when you're starting out on this and you're brand new is to have that consistent root gap, that consistent root face. That means if it's 332 at the beginning, 332 all the way at the end. And that goes the same with the root face. You don't have any high-low, you don't have any dog legs, you don't have any inconsistencies in your plate. The problem is when those variables change, our amperage has to change to support those differences, unless we have somebody on the dial. Now, if you're using a bandsaw or a chop saw to cut these bevels, great. You usually don't have any problems. But if we're doing this with an angle grinder and we're doing it by hand, you want to check to make sure that that bevel is staying consistent all the way across. I usually like to finish it off with a flapper wheel. This can smooth it out nicely. Now, when it comes time to put that land on, I like to use the bench grinder. If you're using an angle grinder, try using a hard disc instead of a sanding pad or a flapper wheel. The flapper wheel likes to leave little divots in that land. Now we're gonna set our root gap. A welder once told me that welding is 90% fit up. So we wanna make sure again that we have a nice flat surface, that we have our gap is nice and consistent. So I'm using a 332 filler wire right now. You can use whatever spacer you have as long as it's gonna keep that gap consistent. I'm gonna clamp my plate down and I'm gonna tack from the back side. Remember, these tacks become part of your weld. Not so much with these practice plates, but when we get into pipe or anything where we have to weld from the other side of the joint, those little tacks are gonna be your root passes. So you wanna make sure those are nice and clean. Now, as always, it's gonna be important to clean that material. I'm removing any mill scale, any rust or anything like that. Now, that 6010 is gonna dig through a lot of this stuff, but we wanna keep it as clean as possible. Now that we have our plate tacked up, about 3/4 of an inch long on those tacks, we're gonna feather out those edges. And if you so choose, you can put on your run-on and your run-off tabs. That's gonna help you out when starting. If there's any junk or any lack of fusion, it's gonna go on that run-off tab first instead of going into your weld. I'm using a 6010 1/8 of an inch rod, and I'm set between 75 and 85 amps. Now, depending on the power source that you're using, that may have to be adjusted, so don't be afraid to fine tune it. Now, you wanna have a crisp, stable arc. So you wanna use enough amperage so that you could bury that rod and it's not gonna stub out on you. So if you have an arc force setting on your machine, I'm gonna suggest you turn that up a little bit. I usually like to start in small increments and then I'll bump it up as needed. So if your hole or your keyhole is blowing out too big, then that means you have too much arc force. If it's too little, then you can dial it down. Now, you really wanna have a crisp, stable arc, and you really wanna fine tune it for your liking. Now, too hot and you're gonna blow through, you're gonna create big grapes, it's gonna be out of control. Now, too low of current, you're not gonna get enough penetration and you're gonna get a bunch of lack of fusion. So it's really a balance on this. Now, one thing I should mention is that most hobbyist welders, especially the ones for your garage, do not support a 6010 rod. There's just not enough OCV, open circuit voltage, in that machine to run that. However, they will run a 6011, which is similar, just a little bit softer. Now, if you do want to run that 6010, make sure you look at the specs on the machine to be sure that it's capable of running that 6010. All right, it's time to burn some rod. Here's what I focus on when running that root. Number one, arc length. You want to stay tight on this, about half the diameter of the rod. Sometimes you want to get down in there and we want to touch the plate so that we can break down those sidewalls. Now, a common mistake by new welders is that they hold too long of an arc length, causing the puddle to widen out, overheat, and eventually your keyhole getting out of control. Number two, rod angle. We want to drag the puddle. We want to keep between a 5 and 10 degree angle off of 90. We don't normally push the puddle when welding in the flat position. We want the solidified metal behind us to support the molten metal ahead of us. Number three is our travel speed. We want to move steady across the joint, preventing any undercutting or excessive keyholing. Traveling too slow will cause your joint to overheat, eventually grape, and cause a whole big mess. Now, traveling too fast can cause undercutting and lack of fusion. Now, when it comes to technique, I like to use a slight whip and pause motion. Whip forward to open the keyhole, Then pause slightly to let the metal fill in before moving on. This is a bit like a sewing machine. Move forward and dig down. When you pause, the rod comes up. If you see the keyhole getting too big, tighten up your arc and start whipping further out of the keyhole, allowing the weld behind you to cool off. Using that keyhole technique allows the welder to listen. We can hear the backside of that groove, break the sidewalls down, and penetrate enough onto the backside of that groove. Keyholing, whip and pause, stepping, that's a super common technique for welders to use when welding that open root. However, another technique is just to drag that root in. Usually a more experienced welder that understands their settings, their root opening, their land and all that, can get that setting just perfect and drag it right in. After running the pass, take a look at the backside. You want a nice consistent bead with good penetration, no excessive buildup or lack of fusion. If you see gaps or lack of fusion, it might mean your settings or technique needs some tweaking. Now, generally speaking, and it all depends on the procedure, however, your root should be no larger than a dime high. Remember, we're trying to make that weld bleed through onto the backside of that groove, so we have to keep that rod nice and tight and into that joint. Now, in general, the thicker the plate, the easier it is to weld. This is why I suggest starting on 3/8 and maybe even thicker. However, if you're welding on 1/4 inch plate, it's completely fine. It's going to be a little bit harder to weld. Your plate's going to overheat a little bit more. You might want to tighten up your gap, give yourself a larger land, or even step down a rod size. We're using a 1/8 rod on that 3/8. You could come down to a 3/32. When it comes time to do a restart on an open root, it can be a little bit different than normal. We want to make sure that we feather out our tacks or that we ramp that stop. I like to strike up behind, warm up that weld a little bit. Once we get to that keyhole, drop down, pause for a half a second, and then continue on. If we strike up and hover over top of that keyhole and then move in, sometimes we get lack of fusion. On this one here, you can see a good tie-in, and then back here, you can see a poor tie-in. And that's how you lay a solid 6010 open root pass on a 1G plate. Please like and subscribe if you enjoyed this so I can continue making great content. If there's something I've missed or something you need clarification with, let me know in the comments. So as always, keep your lenses clean and we'll catch you on the next one.